Hi there, hope you are doing well. My name is Vadiraj Joshi. Today I'm going to demonstrate about my capstone project for IBM Coursera and have chosen to work on a stock predictions use case. I have prepared a small presentation to give a walkthrough about this project, and here's the agenda. The use case and the data set selected for that, exploratory data analysis, data cleansing and the wrangling part, model definition and training, last, model evaluation and tuning. Let's dive into the use case. I've chosen a stock prediction and I named it as a stock predictor, which will make market predictions based on a stock data for Dow Jones specific to this use case and the news headlines for the past 8 years. As we all know, stock market plays a very important role in a modern economic and a social life. Investors always look for ways to increase value of their assets by investing in the stock of the listed company. In the past years, researchers mainly constructed statistical models to describe the time series of stock price and trading volume to forecast the trends of stock returns. It is worth noting that the intelligent computing methods that exist today, represented by ML algorithms, also present a vigorous development in stock market prediction. With the various data sources, thankfully there are different set of data sources exist today, such as multi-source heterogeneous financial data, high frequency trading data, rich and diverse technical indicators data, macroeconomic data, policies and regulations data from different countries and agencies, market news which is specific to this use case, and social network data. So with this data set, which we term as alpha data or alternative data, stock predictions have become more accurate in today's world, and also going forward they will become highly accurate. So who will be using this stock predictor? Currently the stock predictor is designed for one company, but it can be extended for different companies listed on NASDAQ. And it can be also used by brokers and financial advisors of wealth management firms and look into insights on the seasonal trends and growth, which can be analyzed using this model. So with that, let's get into the data understanding part. As I mentioned, it comprises of news, market news, and the stock data. And I have chosen a data set from Kaggle platform, and it's titled as Daily News for Stock Market Prediction, which is an interesting data set to work with. And it comprises of news data, which is crawled from Reddit World News Channel, and the stock data from Dow Jones Industrial Average. So I can quickly get into my notebook, and here's my stock market price prediction notebook that's available on Watson Studio, and which gives a brief overview and the steps taken. And I've used the IBM data science methodology by John Rollins, and you can get into that details using this URL. So I've started importing the libraries, and the section 1 talks about data quality, and 1.2 starts with the exploratory data analysis. And this is the data frame, how it looks, the combined stock data. So I've used these data sets, the combined news, the Dow Jones Industrial Average stock data, and the combined stock data for the same. This is how the data frame looks like. And further moving on, it talks about data quality, section 1.3, and each features is listed here. And this is the exploratory data analysis part, which talks about how the different features are distributed, and more or the less they are normally distributed. And here's the explanation of each plot. And further, it talks about subjectivity and objectivity versus stock data. And the section 3 talks about a feature engineering. And before I explain the notebook further, let me jump to my slide, and the next part is talking about data cleansing and wrangling part. As I explained on my notebook, there were no much outliers, and as you can see in the bottom right corner, the data is normally distributed, not much data skewness. The one part that I would like to highlight is each row in the headlines data set was iterated over an algorithm which generated the subjectivity, objectivity, positive, negative, and neutral sentiments, and only a single sentence was providing the respective sentiments. So what I did was I modified it to iterate over all the individual rows and simultaneously create those sentiments. And the next part was concatenate the top headlines from 1 through 25 and then pass it to the algorithm to make it more efficient. And um, moving on to the next slide, this is how the EDA looks like, and this is the correlation matrix, and I can show it on my notebook as well as a part of section 3. I'm switching over to the notebook. As I mentioned, there are no much outliers, only 7 of them, and I think I used average to fill in the NANs, and this is the correlation matrix. Moving on, the training part. So I considered some of these classification algorithms, the logistic regression, LDA, KNN, decision trees, naive Bayes, support vector classifier, and random forest classifier. And I defined them as a list. Let me go to the modeling part on my slides. I'm switching over to my slides here. So now that we are done with the model definition, and now that we are done with the data set, having completed the data set assessment, trend analysis, data distribution, and having a good insight in the data set, we can move on to the model definition. So one thing that to be kept in mind is that this is a time series problem. So it is important we do not randomly pick training and testing samples. So I'll mention that in the evaluation part. So this is the model definition where I defined all the models as a part of list and the training part. So as I was talking just a few seconds back, the chronology of this time series data set has to be preserved. So when we are doing a train test split, where I used 70% of this data in this use case and 30% rest of the 30% for testing the model. So the chronology was kept preserved. So also data distributions are in varying ranges. Sometimes getting all data to same range helps better train the model. That is something I learned in this exercise. This is a small code snippet to calculate the accuracy of each model in the list. And here's a quick results. And the logistic regression 53, KNN is 45, 57, naive Bayes 53, SVM 53, random forest, and the XGBoost 58. So one thing to note is LDA shows a 94 out of this entire set, and that looks fishy. So I calculated and evaluated the model. When evaluated the model, it showed the confusion metrics and the classification report also came well for the LDA model, but however the ROC curve was not promising. So I had to drop this and take a detour, and I started a feature engineering. So I'm switching back to my notebook, and here's the score of each models that you just saw on my slide, and the confusion metrics and classification report for LDA, and this is for XGB classifier, and this is the ROC curve for LDA, which is not good, and I had to take a detour with a random forest classifier. So I did a feature importance before improving the score of the model, and this is my feature importance and feature extraction. So I furthermore some more feature extraction part. So I used Plotly for plotting all of this, Here's a code commented. Okay, here's the XGB classifier with hyperparameters defined, the max depth with 12 and 1000 estimators. After completion of the training, the model score is 94%. So I forgot to mention one more part is I also used a PCA, principal component analysis, to reduce the dimension of the data, which helped me increase the model accuracy. So I printed the confusion matrix along with the classification report, which looks nice. And just to be sure, I plotted the ROC curve, which is 98%. So with that, we concluded this model is performing good with a 94%. So quickly turning to my slides, the tuning part, as a part of the summary, the conclusion that this suggests that our model is performing good at an accuracy of 94%. So that's the conclusion of my presentation slide. Now switching to my notebook again. So what are my next steps? So I would definitely try the Arima model on this further, and the Prophet from Facebook, and deploy this model in production with an endpoint using REST API with a Flask web framework, integrate it with any client-facing application such as wealth management apps, and integrate with the bots such as Watson Assist, the conversational AI for stock recommendations. So I would like to switch to one of my high-level architecture that I developed to quickly explain. As an end user logs into the system, definitely through the Identity Access Manager, IAM, and once the entitlements are verified, authorized to access the system. So as you can see, there are three main components: the Watson Assist, which is in a front-facing bot, the conversational AI, actionable insights to provide all the recommendations, and the real-time processing engine to work on the transactional part, and also the market data and the news data. And this is the enterprise data which is specific to Dow Jones now, which will have all the DMAT, income, assets, life events, planning, and all that in the enterprise data here. So you can see an arrow mark, which is a transformation and connectivity layer, which will do a lot of transformation between enterprise and the data layer. The integrated data will have all the data from the enterprise, and the social data through a third-party API from social data in a public domain will have all the social data, and all these are merged into the material master data, which is fed to the analytics and machine learning layer, which will have all highly trained machine learning algorithms, one of them being which we just saw a few minutes back. So with that, the Watson Assist will get all this processed message from the machine learning layer, which will be presented to the UI manager and then to the end user for questions such as predict my stocks, impact on my portfolio, and top stocks to pick based on my portfolio. These kind of questions can be answered by Watson Assist, which is a conversational AI. So that's a very high level architecture that I just wanted to present. And with that, we come to a conclusion of my capstone project. Thanks for hearing me out, and always stay curious. As we all know, power of fintech is reshaping the financial market and changing the format of finance. Thank you very much. Have a good day.